Hi, let's solve one previous question of code generation compiler. This question was asked in GATE CS 2013 question number 49. It is a linked question with question number 48. I already solved question number 48. Just go through that lecture. The following code segment is executed on a processor which allow only register operand in its instruction. Each instruction can have at most two source operand and one destination operand. Assume that all variables are dead after this code segment. One code segment is given. Question number 49. What is the minimum number of registers needed in the instruction set architecture of the processor to compile this code segment without any spill to memory? Do not apply any optimization other than optimizing register allocation. Will not apply any optimization and any spill, and it is saying how many registers are required for writing machine code for this code segment. Let me write code for this. First we'll do for this statement. Let me take two registers. One is R1, another is R2. Now R1 will contain A, R2 will contain B. If you see after this statement B is not live, B is dead. So what we can do, we can store result in R2. Let me write code for this. C equal to A plus B. We can write R, R2, R1, R2. R1 contain A, R2 contain B. Now result will contain by R2. So this R2 will contain C. Next statement D equal to C multiplication A. C is in register R2, A is in register R1. We can simply multiply it. And D is live. D have some use here. So we need to keep D in register. So for that we'll take another register. D equal to C multiplication A. We can write multiplication R3, R2, R1. Now we'll take another register R3 that will contain D, as D is live. D have some use. Next we'll do for E equal to C plus A. C is in register R2, A is in register R1. And E is also live. E have some further use. So we need to keep E in a register. Add R4, R2, R1. We'll take another register R4 that will contain E. Next, x equal to C multiplication C. C is in register R2, and after this statement C is not live. We can keep result in R2 also. So multiplication R2, R2, R2. Means this R2 contain C, this R2 contain C, and result will be in R2, means this R2 will contain X. Now R2 will contain X. Next we need to compare if X greater than A, Y equal to A multiplication A. A is in register R1, and after this statement A don't have any use. A is not live. So you can use the same register. So Y equal to A multiplication A, we can write as multiplication R1, R1, R1. Now this register R1 will hold Y. Next we'll do the else part. D equal to D multiplication D. D is held by register R3. So you can write multiplication R3, R3, R3. So R3 contain D, this R3 contain D. Now the result will be held by R3. Result is also D, but this D is and this D are different. This is the updated D. So now R3 will contain D. This D value will be updated. Next statement E equal to E multiplication E. E is in register R4. So you can write multiplication R4, R4, R4. Now result will contain the updated E. And the question is about minimum number of register. We require 4 register for writing code, and 4 is in option B. So answer will be option B, 4. We require minimum 4 register for writing machine code. In previous question, question number 48, with spill and with core motion, we did in 2 register. Here, without any optimization and without spill, we require 4 register. If this lecture is helpful for you, please like and subscribe. Thank you.